Hi, sixth graders. Your lesson for today is telling you a little bit about, comparing and contrasting histograms with bar graphs. So you will see that I have both a histogram and a bar graph up here. And what I want to show you, is why we might choose a bar graph or why we might choose a histogram. So the first one I have represented up here is a bar graph. And with this bar graph, it's very much like what you would have done in elementary school. I have the categories down here, so I graphed students' favorite colors. The different colors down here: purple, green, orange, blue, red, black, pink, brown, teal, and yellow, and the number of students who would have responded over here on the side. The bottom is a better representation with a histogram, and this is the height of students. So remember all of that pretend data from those first couple of lessons where I had all of the pretend students with the Barbie dolls and the Ninja Turtles and Woody and Buzz and all of that. And if you remember way back on that day, we showed you two different kinds of frequency charts. One of the frequency charts was this one. Rather than having every single piece of data listed, we grouped them. So a height of 0 to 9 was 8 students. A height of 10 to 19 was 6 students. A height of 20 to 29 centimeters was 4 students. And a height of 30 to 39 centimeters was 3 students. So I did this way back on that initial day because I knew we were going to be teaching about histograms. So what you can see here with the histograms is we have that same 0 to 9 as what we have over here, and 8 students. 10 to 19 centimeters, we still have that same 6 students. Likewise, we have 4 students and 3 students. But what I want you to take a look at, initially, what's the major difference that you see between our bar graph and our histogram? And what students notice right away is that the bar graph, there's gaps between the data, and histograms, they are side by side, they're touching. That's called adjacent. So what I have over here on my whiteboard is kind of comparing and contrasting the two, and I'll take you through those lists just so that you can see the difference. Both bar graphs and histograms have a title, both have an x-axis that's labeled, both have a y-axis that's labeled. The x-axis is the thing that you're measuring, so the thing is favorite colors, the thing is height in centimeters, and the y-axis in both is telling you how many. So they are set up with your x, your y, and titles the same. They both obviously use rectangular bars. The scale of the y-axis is also something that you have to take into account with both of them. For example, I counted by ones on both of these scales, but if I were trying to graph everybody at Arbor Hills, well, my graph would have to go a whole lot higher than 8 on both of these. So I might count by 5s on both, I might count by 10s, I might count by 2s, just like we did in that variables and patterns book. So you just have to pay close attention to what your scale is on your y-axis. Also, just like in our variables and patterns book, I know we spend a lot of time really talking about evenly spacing your data. So you can see that I kind of like skip counted it for every single one of these. So no bar, then a bar, no bar, then a bar. For each of these on the histogram, I made them 5 wide just to kind of spread my data out, just like we would have done in the variables and patterns book. So those are things that both of them have. But let's get a little bit more specific about what is particular to a bar graph compared to a histogram. So in a bar graph, the x-axis order does not matter. Up here I put purple, green, orange, blue, red simply because that's the order that I pulled my Sharpies out of the bag. And if that was in a rearranged order, that would have been completely okay. They don't have to be in any kind of order. They don't have to be alphabetical. They don't have to be tallest to shortest. They can be in any order whatsoever. So if I were graphing what month were you born in, I guess logically you would have maybe started from January to December. But in reality, some of us, like teachers, I'm kind of on a school year calendar, and a lot of times my brain thinks from August to July. And I can get my agenda book as August to July. So technically order doesn't have to matter with your bar graphs. It can, like if you're doing what month were you born in, but some of them can be really random in their data. However, in your histogram, the x-axis order does matter. When I'm talking about the heights of the students, they have to go from least to greatest with what I do. They have to be in that order. In a bar graph, the bars have a gap between them. But in a histogram, this word is adjacent. So the bars are side by side, which is known as adjacent, no gaps in the middle of them. The third thing I want you to notice, and this is really what's the most important, the data is not continuous. The word for that is called discrete data. There's like one answer to that, and it doesn't progress from one to the other. So purple doesn't progress to green, it doesn't progress to orange. It's completely individualized. However, when I talk about heights of my students, it is continuous. If I were to line everybody up, their heights are going to be continuous. Your growth is continuous. And that is called continuous data. Data is continuous and in order. It can take any value in that range. Other examples of what continuous data might be, you might have something like height, obviously, or weight, or time. Those are continuous. They just keep on going. So that's a little bit about the type of data that you would put on a histogram versus a bar graph. What I really want you to notice is something about this histograms with those intervals. They must be evenly spaced, and that is the most common mistake students make when they're making histograms. So I gave you two separate pieces of data here to kind of look at, and Mr. Lynn, if you would kind of zoom in just to make sure everybody can see what I'm talking about here. So this would be correct. This is the data I have up here, 0 to 9, 10 to 19, 20 to 29, and 30 to 39. And if you notice, on first instinct, students say that those are 9 apart. 9 minus 0 is 9. 19 minus 10 is 9. But take a second and think about that. You're really graphing a gap of 10. Let's count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's really 10 pieces of data, even though you're subtracting and get 9. 19 and 10. Again, subtraction is 9, but really 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, that's 10 pieces of data. And there's 10 pieces of data in each of those. That is correct. Now here are the two most common mistakes. Let's look at this one. The most common mistake is that students will go 0 to 10, and then 10 to 20, and then 20 to 30, and 30 to 40. And on first look, that sounds okay, except what if you have data that is 20? Where would you put it? Would you put the 20 with this one, 10 to 20? Or would you put it here with the 20 to 30? And that's where that one gets confusing. That's where something like this is definitely the way to go. Now I want you to kind of notice some patterns, because once you start making your histogram, these patterns are great. For example, 10, 20, 30. We see a pattern with the zeros. 9, 19, 29, 39. We see a pattern with the 9s. Now we see that same pattern here. That's why that one's deceivingly, you would think it's right, but it's deceivingly wrong, because that 20, that 30 are in both locations. Here's another one. This is something that students do too. It kind of looks okay, like 1 to 10, and then 11 to 19, and then 20 to 29. It looks okay because no numbers are done twice, but if I go from 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's 10 pieces of data. But 11 to 19, 11, 12, 13, 14, 15, 16, 17, 18, 19, that's only 9 pieces of data. 20 to 29, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, that's 10 pieces of data. I can't have 10 pieces of data, 9 pieces of data, 10 pieces of data, 10 pieces of data. They have to be evenly spaced, just like we talked about in those previous books. Okay, so here's one more set of hypothetical data. Here would be correct if I'm counting by 5s, like 1 to 5, 6 to 10, 11 to 15, 16 to 20, and 21 to 25. Those would be correct. I see a pattern of 5s here. I also see counting up by 5s here. Wrong. That same reason that this one's wrong. It goes from 0 to 5, and then 5 to 10, and then 10 to 15. We have those overlapped numbers. And then lastly, I just gave another piece of data where you could see the incorrect because of counting mistakes. For example, 1, 2, 3, 4, 5 has 5 pieces of data, but 6, 7, 8, 9 only has 4 pieces of data. So I can't count by 5s sometimes, and then sometimes counting by 4s. And that's when we start to make our own histograms. Hopefully later in the week, we'll be able to make sure we understand what we should be counting by so it's the same number each time. So there you are in a nutshell, kind of the difference between histograms and bar graphs. Bar graphs were definitely something you focus more on in elementary school, so we're going to be sticking to histograms now to make sure you understand those. Have a great day.